Hello! In this episode of FUM0077 machining, we are dealing with this box of worms. Actually this is an UPS which has become an oops. At the moment it's just a very heavy extension cord and nothing more. Well, it should supply current during the brownouts or total power failures, but now it doesn't work. So we open it, we will check what kind of things we find there, and we try to repair it. Okay, so let's first open it. First we open the 4 screws here. In every corner we have a screw and one in the middle. 6 altogether. So I need something to put all the things I find here. Here. And let's start with these screws. Well, this is a quite old Finnish product. This is not Chinese, and this is supposed to last a lifetime actually. But even the best products contain components that will not last a lifetime. In this case it is the... Well, I'm making an assumption here. What is wrong? It is most probably the batteries. And this is really horrible. This is heavy. This is, well, it's really heavy. You don't want to drop this one on your toe. And what we will find inside is a lot of dust, I believe. So the first task is most probably is to vacuum it. Okay. Is there something else that is holding us? Shouldn't be. Okay. Oh yeah. I will bring you nearer so you can see. Oh man. Delicious. And this is, what we have here inside is a fan. I don't know whether that works or not, but maybe it works. And then we have the batteries on this side. We have 4 altogether. Okay, I'll vacuum this one now. There is a thermo element. Okay. This side is quite clean. Okay. Now I will take the batteries away somehow and then I will check these. These are probably the root cause of the problem. This is simpler than I thought. You just unscrew a few screws here. Hopefully I can get it out from there without... Okay, yep. And without short-circuiting the batteries. They might have a current. There is no guarantee that these are destroyed, but I believe they are. How on earth is this supposed to work? Aha, okay. Yeah, okay. This is... Okay. Yeah. Okay, now we must remember the polarity. Oh yeah, we have here something has been leaking here. This one has been leaking. So I have to mark these, otherwise no, I don't need to do that because these go to minus. Okay, this goes to plus. This is probably okay, but we will see to that. This one looks like it has been leaking. So this is minus, and this is plus. This has been leaking. I put these there, here, now I don't, so I don't. This looks good outside. And the last one. Oh, okay. Interesting. Okay. So this is a 24 volt system. So one battery is probably totally dead, and I don't want to have this stuff anywhere around me. This is something. I don't know what it is, but it might contain acid. Okay. Now let's make some room on the table. I will start testing the batteries. Okay, what we have here. I'm testing these batteries for some how they react things. And the standby current, so no load, no nothing, is at the moment 13 point something volts. This means that all the cells are active and they are probably okay-ish, but I have to check that one. I believe these are this battery. Now when I start to, I have here a current limiter which I can use to rise the current into the battery, and when I rise it somehow, oh, this doesn't want to, okay, now let's put it there. You can see that on 0 amperes, nothing input into there, it's 13 something, and if I put, wrong supply, if I put half an ampere there, which is normal, I get 18 volts. This means that these cells are dry. They are uniformly dry. Not a single cell is drier than others, they are all a little bit dry. So this is the story of this battery. It's dry. Okay, otherwise, but dry. So let's mark it dry. Okay. Dry. But good. Dry but good. Next patient. And this one is, now there is nothing in the output. Oh yeah. Nothing in the output. 13 volts. All cells are okay-ish. And now I increase the current. It in half amperes, 18 volts. Dry. This is also dry. It shouldn't go that way up. Not at all. Okay. So mark it dry. We have to add water into this. This is what this means. And then next patient. No current. Just measuring the standby. Oh, 4 volts. That's bad. Well, I don't want to try to charge it now. I will just add water. Let's mark it probably defect. So this is probably defect. By the way, this can operate with 2 batteries only, if needed. It just doesn't supply current so long with 2. The best solution is to have 4. Oh yeah, okay. And this one then. Well, same story, 3 volts. Okay, so these 2 batteries are probably a little bit whatever. I need to open all of these. So let's first see what we have. Okay. There. So, what we have here? Now, this is ordinary tap water. This is rain water, and this is the battery. And this one here, I try to use this one as media to put this. I have loosened these caps already. Just put them there so they don't attack me. This really contains battery acid, and this is a quite horrible thing for your tools and whatever. It's sulfuric acid, and if you have it on your fingers or clothes, it won't hurt you immediately. It will take some hours, but after that you will have a hole in your clothing, and you will also have a hole in your skin. It will impact you quite soon. Okay, everything is now away. So then I look inside there, see what's inside. Well, it looks pretty dry. Oh, yeah. So, let's take one glove off and start putting some water there in. Hopefully I can do this without... oh, this is... doesn't go into the hole, it goes somewhere else. Okay, that goes into the hole. This is a really slow process and it takes a very long time to finish. Okay, I could just drop it there and it will fill it. Yeah. An injection syringe would be better, probably. Okay, I will do this this way. I will do every cell and fill them up, and after that I will start to charge this one. Here is my automatic battery charger. Well, I constructed this quite a while ago. Well, it has microcontroller in, and because this is a lead acid battery, we choose lead acid. Well, and then we choose which current range we will be using. So we will be using the lowest because we want to charge this slowly. And then we just push go. There you go. Now it will automatically detect the number of cells from the voltage, and it will initially test the battery. Well, we could actually see what happens if I choose this one and I choose a little bit more this range, which is quite a lot more. It's 3 times. This should break the charge in the test phase because now it rises the voltage, and if it goes beyond the threshold, it will like that. So we have to charge it at the start with the lowest setting. So then after a few hours we might get it done. Then I will show you something here. Now, wait a minute, this is not very good, but that's really good, and now we can, okay. Now, as you can see, there are some puddles of water here. Well, some of them have consumed the water. I will add more whenever is needed like that, and there you go. It will bubble the air away from there. This is so slow process that it. The last one is also almost empty. Yeah. So we just wait. This is time consuming when the battery is originally a little bit dead. You have to wake it up very gently. Batteries, they are all terminally defective, every one of them. They have one cell that is completely dead, doesn't accept current and whatever. And all of them have a very high internal resistance, which means that you cannot load them very much. Even as low as 200 milliamperes, meaning 0.2 amps, will drop down the voltage down to 8 volts or something like that. Not very good. And I tried every trick in my what I have access to. I have a very good battery reviver unit, this automatic charger, which is using trickle charge, and then it cycles the battery, and it didn't do the trick. I tried constant current charging, high current, and whatever, didn't help. I even used the best possible distillation product. Well, of course, this was the rainwater outside. The original contents, well, that's also helpful, but not for batteries. Because of this, I decided to replace the batteries with new ones. These are unusable. So let's see what I do with them. I don't put them in use directly. I will check that they are in proper condition, fully loaded, and so on. When you buy a new battery, there is no guarantee what's inside of that. What is the state of that battery? So therefore, we will check each one of them and see what is the state of each of the batteries. Okay, here is now the system how I am going to measure the state of the battery. First of all, we have my battery charger here, and then I have a multimeter, and then a few wires here. So first we connect this everything. So let's take the minus here and put it to the minus terminal of my multimeter. There you are. Then it continues from the amp side here. From the amp side it goes to the minus terminal of the battery. So there you go, to the minus side. Yep. And then we take the plus terminal, and now we use a different cord, put it here, and it goes to the voltage measuring side of my multimeter here. Okay. And then the same way we put this terminal to our battery, to the plus terminal. Here. Okay, we probably could use this another way around like that. And now we could first of all measure the voltage there, 20 volts. So it's telling us 11.83. Normally these batteries should have something like 13.8 volts when they are completely full. Is this visible? Yeah. So let's turn this thing on. The nice thing about this connection type is that now I can measure not only the voltage but also the current just by simply switching here. And I can measure either one of these now. And now this charger has a system. First we choose the battery type, which is PV, meaning lead. And then we choose the watts we are going to use here. Let's try with, because I assume this should be quite full. So I choose a lower, this means 3 watts. And then we just go on. It will try to, as you now see, it tries to rise it, and it could easily rise it to 13 volts. So let's make it a little bit less power. Okay, now it goes. Well, it looks like this battery is full. Okay, because this doesn't want to, I have adjusted it in a way that it won't charge a full battery. Sometimes it doesn't show anything here. It should. Why? Okay, I inspect this one. So I have, this is a typical thing. We should actually calculate 6 cells. It doesn't. Now it assumes we have 5 cells there, and therefore it's full. Okay. So we need to use the normal power supply for these batteries, and I have to fix the software on this one. Yeah. Since my automatic battery charger has a software fault, oh damn! So therefore I need to do this the old-fashioned way. So here we have one battery which is connected to this power supply. So if I disconnect the battery, you will see that it climbs to 15 volts and 0 amps. So I have limited the voltage to 15 volts because it reads in the manual of these that you shouldn't charge above that, but that is allowable. Okay, then we do that. And then I have limited the current to half amp here. And it will, of course, not when it rises, and now you can see it's 13.5 volts. That's nowhere near full. It should be at least 14 volts, then it's full. So this was totally empty actually. Okay, let's measure what has happened here. It has been half an hour now, with half amps for each battery, and I actually lowered the voltage limit to 14.5 volts. So let's see what is in here. Okay, 14.2, 13.4 and 14.1. So a little bit more to go. Here is the well, battery spaghetti bolognese. So these batteries have been sitting here overnight, 10 hours, charging with low current. At the moment they are having 14 volts and 160 milliamperes. That means 40 milliamperes per battery. That's quite low current. 0.04 amps. And they are really at the 14 volts at the moment. Now what I will do next is, they are all in parallel, connected in parallel. Therefore this horrible spaghetti. So what I will now do, I will disconnect them all and then measure the individual cells, individual batteries, what is their voltage. And now let's disconnect these animals. First, let's ensure that you see that's not a good position. I believe that's good. Yep, okay. So now I just measure these batteries individually. So the first one is 13.86. That's a full battery. Next one, 83. Okay. 80. And finally, oh, this is not 100% full. This is 72. It's well, it's practically full. Maybe 1% of charge is missing. I don't know, but it's a little bit different. Well, constructing this one is nothing but easy. So, well, I just start up by connecting the battery. This is the plus. You can tell from the color of the wire. And then I put this. Okay, I will put the batteries in and then we start testing this one. Okay, now the batteries are connected in there. And well, let's turn it on. There are two switches here. The lower one is for the mains, for this incoming from the the big network, and then this one is for the batteries. And now let's turn this on. See what happens. Sometimes, yeah, okay. Well, now it's outputting power, but the batteries are disconnected. Well, I have connected this Dremel into it, and it now starts running. Yep, okay. Now we can hear that our Dremel is running, and if I switch off from here, and as you could hear, it ran quite a long without the mains. This particular unit is designed in a way that it's generating. There are two types of UPS. One that is connecting normally the mains power directly into your device. And then there are devices like this one, which is actually not directly connected to the mains, but it first rectifies the current and then it turns it back to 240 volts or 30 volts AC. And this is a more reliable thing. When there comes a brownout, this will compensate immediately. The ones that operate with, let's put this now on, operate with the direct method, they are not so very good. And this Dremel is really, well. Okay, let's measure the battery at the moment. What it is, the voltage should be somewhere around 26, I believe. 26.8. Hopefully you can see. Let me check. Yeah. So it's 26 volts. And now the next thing I will check is whether it is charging the batteries. Yeah. Dremel is now running. And 26.8. Now let's connect the batteries. Batteries are on. And this should be a little bit higher now. 26.8. It's not. It should be higher. Well, is it not charging? Let's put this away then. Now, when I turn the mains off, it still should be continuing to run. Yes, it does. and it will be start beeping, and this one should be, yeah, it's going lower. Now it's signaling that we have a power brake. Yeah, okay, and now when I turn it back on, the mains, well, yeah, and now it was 20.2, 3, 2.3, 26.3. How could I keep these here? No. Point 1. 0.3. Okay. It might be charging. I'm not sure yet whether this drop is just because it loses the load, but let's see. So now it seems to operate. Well, the Dremel is not a heavy load, but well, when it's operating, it would be, yeah, okay. It works. Oh yeah, it is charging. Okay. Well, just put the cover back on. It's vacuumed. It's decently clean. New batteries in. Huh. Ready to go back to service. So here is my server. Now we have a warning light here, meaning that the other power supply is not getting any power. Well, this particular server has two power supplies, one of which is connected always to the mains, and the other one is going through this UPS. So when the power fails, this will take over and keep it running for a while, maybe on half an hour. Okay, and now let's switch the mains on first. By the way, this also supplies the rotors, and well, now it's on. The yellow light should turn off. So it did. And now there is my rotor. This is a VLAN station, and then we have the thing that is connected to the public network. So now let's put the batteries on. Batteries are connected. Okay. And now what I will do next, I will switch off the mains. Yeah. The yellow light didn't come on. Okay, if I switch this off as well, then the yellow light comes back on right away. Okay, good. Back on. Let's wait, it beeps. Okay. And as you can hear, the other power supply started there. And now this should turn off. Yep. And well, we put the battery on. And it's ready for use. Okay, so now we have a working UPS, which is no more oops. So, well, as a conclusion, I would say that first of all, this paper states that the life expectancy of these batteries in this type of use is 3 to 5 years. So that means that the batteries are a consumable item in this. Fortunately, in this case, the UPS is really good quality. The device itself doesn't break up. Just change the batteries every 5th year and you are good to go. And these old batteries became totally useless. Well, it's a battery destroyer, one could say. Okay. Well, I would say I'm really satisfied. The batteries are well, about 80 euros, all 4 of them. And now they last for maybe 4 years. It's okay. And now, in the next episode, we will be dealing with this one. I have done some, there are 3 potentiometers, and we will start testing this unit in the next episode of Pin Open Machine. Till then, bye!